Hello everyone, my name is Yunlei Tang, and I'm a senior student majoring in economics at Purdue University. Today, I would like to discuss customer churn prediction on telecommunication industry. Here is my entire poster, and I will present each part. This project analyzes the factors that influence customers' churn in a telecom company. It is important for a B2C company to predict customer churn because it helps the company identify and proactively reach out to customers at risk of churn and try to repair the relationship beforehand, reducing the risk of lower revenue for the business. I analyzed the factors have a great impact on customer churn and brought the company's attention which type of customers have a high probability of canceling their subscription service. I also built several models such as lasso, logistic regression, KNN, and decision tree to predict the probability of customer churn. This analysis is important because when the company predicts a high probability of customer churn, the company can take action to avoid it. Customer retention has always been the most important factor driving revenue for retail companies, especially in the telecom industry. Customer retention will directly impact a company's overall revenue. Therefore, the churn rate is a key factor in evaluating the longevity of a company to achieve revenue growth. The main stakeholder of this study are telecommunication companies, and our goal is to build predictive model to help them accurately identify customers at risk of churn and which factors will impact customer churn to help them improve customer stickiness. These two graphs shows that first, customer retention ranked number 1 in retailer revenue drivers, indicating the importance that should focus on. And the churn rate in the telecom industry is at a high position and needs to be addressed urgently. Therefore, my research questions are which significant factors lead to customer churn, and how well do predictive models help us predict customer state? Compared to other research, my breakthrough is using more technologies to compare the most accurate models. Data is from Kaggle, including 7,043 observations and 38 variables, which can be categorized as following. First, customers' information, such as gender, age, marital status, lived city, family status. Second, service purchase, including the type of service purchased, usage, and amount. Finally, customer states at the end of the quarter, including reasons if customers are lost. Through explored data, we can get top 3 churn reasons are competitor had better device, competitor made better offer, attitude of support person. Churn rates are higher in the first 6 months of customer purchase. We define high volume customers as those whose contribution exceeds the average revenue. In this case, we can summarize they are married people, are more interested in offer A, B, or none. All more detailed surveys are more than 50% subscribed, preferring long-term contracts. The trend customers profile is that they are unmarried people, offer E and none are more popular, and more than half of people would not consider detailed services, even though they have purchased broad categories of services, preferring monthly payment orders. Then I prepare the data by replacing missing value and outliers with 0 if it is a numeric variable, and no if it is a categorical variable, dropping useless variables to simplify the target variable as a binary classification problem and standardization all the numeric variables. This is my methodology. Firstly, I collect the data and explore the data for better understanding. Then I prepare the data mentioned on the last slides. And then I prioritize the data as 60% training set, 20% validation set, and 20% test set. Then I build 4 different models, which are lasso, logistic regression, KNN, and decision trees. Then I choose the candidate model through the criteria that the difference of R-squares and misspecification between train and test set should be not exceed 50%. And finally, get the best prediction model by compare the R-squares of the test set and misspecification. The statistical performance is shown here with the chosen reason, the train test R-square, misclassification rate for test set, and significant variables. Statistical performance measurement I use is R-square, which represents the proportion of variance of the dependent variables explained by the variable in the regression model. If the R-squares difference between the training set and the test set is greater than 15%, the model is overfitting. For these 4 models, all are candidate models. Then I compare the R-squares of the test set and the misspecification rate. A larger R-squares and a lower misspecification rate is considered as a best model. In this case, logistic regression is the best model. In the logistic model, the number of referrals has the greatest impact on customer status, followed by contrast, merit, and so on. These are important predictors for telecom companies to looking out for. The model can be applied to the telecom industry to help them predict the future status of their customers based on their basic information and purchase services, to better target potential high-volume customers. In addition, important factors that influence the result of the model can motivate the enterprise to make some adjustment and provide better services to retain customers. Next step, we can cooperate with consulting firms in the future to provide report to the telecom companies to provide suggestions for their business expansion. In addition, we can expand our predictive model to the market to collect more data for improving accuracy. To conclude, it is necessary to have a good prediction of churn so that telecom company can better identify potential high-value customers and achieve revenue growth. The number of referrals has the greatest impact on customer status, followed by contrast payment form and the marital status. Our models prediction the future state of customers with 85% accuracy. The limitation is, first, K4 is more appropriate for data partitioning, but because of the limitation of Jump Pro, I use the validation set method here. Moreover, adding more transformation variables or other features can increase the proportion of variance that the model explains for the variables.